Hi, my name is Werner Haig. I'm the chief chemist here at Empower Electronics. I'd like to thank Rick Emery for inviting me to give a little presentation here to the Midwest Hazmat Conference. I'm going to talk today about the ethylene oxide sensors as a complement to PIDs. I'm a chemist with a bachelor's degree from MIT. I then went on to get my PhD in environmental chemistry at the University of Tennessee. Did some postdoctoral work in Switzerland, worked at Stanford Research for a while, and then went into private industry, worked at Ray Systems for 10 years where I wrote the book on PIDs, and worked at Ion Science for a little while, and now I'm the chief chemist here at Empower, where we're trying to get gas detection back up to speed. I'll turn off my camera now to focus on the slides. So I think of the Eto sensor sort of as a poor man's PID because it's very low cost, but does measure a broad range of chemicals, which is sometimes good or bad. There we go. Cross sensitivity is sometimes good or bad. It's always a competition or a trade-off between selectivity and broad sensitivity for any sensor. Sometimes we want to have a highly specific sensor, such as for benzene, whereas other times it's helpful to have a whole host of chemicals being able to be detected, especially for hazmat type of applications, where you can't always predict what chemicals you're going to need to measure. You don't know exactly what kind of spill is coming up or what's out there at different sites. So we can take advantage of ethylene oxide sensors' response to a range of smaller molecules, but doesn't necessarily measure everything. So here's the key chemical that I think is useful that for the ethylene oxide sensors are lower alcohols like methanol and ethanol, even formaldehyde, and these can be detected with this electrochemical ethylene oxide sensor, but give no response or relatively weak response with a PID. So it can measure some of the compounds that a standard PID cannot, and it can do so at much lower cost. Now, these compounds can be measured with an 11.7 EV lamp on a PID, but there are problems with those 11.7 lamps. They have a very short life of only about a month or so, and so you have to keep replacing them, so the operating costs are fairly high. I'm going to focus primarily on the PIDs that are these 4 series size sensors that can be put into a multi-gas detector, such as our poly monitor. This table gives a summary of what kind of chemicals that we have evaluated for detectability. Let's focus primarily on the detection limit, but here we see all these chemicals can be detected in fairly low ppm concentration ranges, whereas on a PID, you get no response for these kind of compounds: cyanide, formaldehyde, formic acid, acrylonitrile, methanol, and ethanol is fairly weak. Ethylene oxide's kind of weak also. Epichlorohydrin is kind of weak. These are some toxic compounds that are best measured with an Eto sensor. There are other compounds that can be measured by both sensors. Ethylene, you do get some cross sensitivity from nitrogen dioxides. Some lower ethylenes, butadiene, can be measured on either one. Isobutylene is detectable by both, or even vinyl chloride. That's a useful and another application for the ethylene oxide sensor, measuring vinyl chloride with a very low cost sensor. By contrast, ethylene oxide sensor cannot measure all of these compounds: trichloroethylene, acetone, benzene, hexane. These are common components of fuels. So at least in gasoline, you can't really measure gasoline, and there's also no cross interference by gasoline. a lot of paint solvents and other industrial solvents like chlorinated solvents, acetone, are not detected by the ethylene oxide sensor, but are readily detected by the PID, and therefore a PID would be better for that. So these two kind of sensors sort of complement each other, with the PID focusing more on the larger molecules and the ethylene oxide more on the smaller molecules. Of course, there are some compounds that cannot be detected by either one, such as methane, very strongly, heavily chlorinated compounds. And unfortunately, we can't measure acetonitrile. That would have been nice. That's one that always has difficulty with the PID. It is possible to use a PID, lower range PID on a multi-gas meter, getting down to roughly 10 ppb. These sensors in a multi-gas meter, getting these lower concentration ranges is difficult because you have the pump usually before the sensor, and the pump can absorb the chemicals. So actually getting down to these 10 ppb levels is rather difficult on a multi-gas meter, whereas on a standalone PID, it's much more capable of doing that. So here again is a summary of how one might implement these sensors. You can put an Eto sensor in a single gas meter. You can have a standalone PID, which is the best way to make PID measurements in a standalone type of PID. This is our Neo MP181. Or you can combine them both into a multi-gas meter, such as our Poly MP400, where you can get oxygen, have a range of other sensors like H2S, carbon monoxide, put a PID in there, put an Eto sensor in there, and you have a lot more flexibility, and you can use that meter for confined space entry as well, if you get the right sensors in there. So the multi-gas meter has the most options here for measuring both Eto and PID. Here's a summary of the ranges. Again, the PID offers the broadest range, has the most capabilities. A standalone PID can get you down into the low ppb range, whereas the PID in the multi-gas meters is just not as good to get down that low. And the Eto sensor has an even narrower range of around 0.1 to a few hundred ppm. Of course, most measurements are done in this range, and that's where most decisions need to be made in terms of toxic levels. And therefore, that's still a reasonably useful monitor, unless you have very high toxic gases or you want to measure up in the explosive range. Here's a summary again of standalone PIDs. Ranges can get from 10 ppb up to 5,000. You have an extended range up to 15,000, and a ppb range down into the 1 ppb to 15,000, all in one instrument. The biggest advantage again is the fast response. It has the wide concentration range, the best resolution, the long lamp life. You can select over 700 correction factors to measure on scales of all these different chemicals, but of course it has a higher cost. But mostly the fast response time of 3 seconds or less is really the biggest advantage compared to the ethylene oxide sensor. The PIDs and the multi-gas meters are more limited, as I already mentioned. You can get a sensor going up to 10,000 ppm and a lower range one with the resolution down to 0.1. But as I mentioned, these low resolutions are really kind of hard to get to in an actual multi-gas meter because the pump is in front of the PID and all the other sensors. But for hazmat teams, it's more versatile, can measure up to 5 gases, include both PID and Eto in one sensor. One instrument, has lower cost, can have the same correction factor list as the standalone PID, but it does have lower concentration range, weaker resolution, shorter life due to the smaller lamp size, and a slower response, more in the order of 10 seconds because the pump is before the PID. Here's a summary now of using an ethylene oxide sensor for VOCs. So this is just the ethylene oxide portion of this, and the cost is low, only a few $100s. Whether it's in a single gas meter or a multi-gas meter, this is the range, typically a few $100s. It's fairly low maintenance. You use it, and when it's done, and you throw it away, get a new one, or just replace the sensor. On a uni single gas meter, you can get 2 years or more than 2 years on lithium battery life, so that's a nice key feature. You don't need to recharge it all the time. It does have continuous measurements, but the response time is slow. The T90 time, the time to reach 90% of full measurement, is 2 minutes. So you need to have a little bit of patience when working with this ethylene oxide sensor. So again, that's the main disadvantage. Only 3-second response time on the PID versus 2 minutes or more on the ethylene oxide sensor. The detection limit is about 0.5 ppm, upper limit range limited to about 200. It is selective for small compounds, cross-sensitive. It does have cross-sensitivity to some of these chemicals that might be in the same workplace. And it can also measure formaldehyde and acrylonitrile and a couple other things like vinyl chloride that might be useful if there are no other interferences present. And it doesn't measure gasoline or most chlorinated solvents. It has, excuse me, no humidity quenching effect. PIDs do have some humidity quenching effect. There's a slight response at very high RH. And then there's no effect of methane, which PIDs do suffer from methane effects if the concentrations are very high in a natural gas type of atmosphere. So here's a summary slide to compare these two sensors. List price for an ETO sensor is only around $250 some, depending on the manufacturer. Probably the 4-size PID sensor is more in the range of $900. These are list prices. The ranges, again, 0 to 200 ppm. The 4 series goes up to about 2,000, although most people don't need to measure that high. The display resolution is 0.1 ppm for both cases. The detection limit is around 0.5 ppm for both of these cases for the standard 10.6 PID. It'll display down to 0.1, but the noise level is a few tenths of ppm, so therefore that's why I put 0.5 as the detection limit. Here the detection limit is limited by the dead band, where the unit just cuts off below 0.5 ppm and reads 0. Again, the main disadvantage of the ETO sensor is the longer response time of 120 seconds versus 10 seconds. For the multi-gas meter PID, it does detect methanol. The PID does not detect methanol. It does not detect gasoline. The PID does detect gasoline. Those are the two broad categories. Humidity effect, again, no response loss here. At high response, high RH, you do get some response loss on the PID. Can be removed using filters or calibrating at high RH, but those are sort of workarounds that you have to understand. Whereas on the PID sensor, an ETO sensor, you don't need to worry about that at all. If you apply a breath test to it, you do get some response. So you don't want to hold this thing too close to your breathing zone. Again, there's no effect of methane, and the PID, sorry, on a 4 series PID, you do get some inhibition by methane, and you can't measure impure methane. Whereas in an ETO sensor, you could actually measure things in a natural gas pipeline. There's no oxygen required for the PID. It is required on an ethylene oxide sensor, but if the exposure is less than about 5 minutes, there's enough oxygen inside the electrolyte of the sensor that you don't need to worry about that oxygen depletion. And so it will still work. You just can't use it in a process control where it's extended exposure to for hours or days at in no oxygen. The warranty for both is about a year, and the life expectancy is a year to 2 years. So you do have a little more frequent replacement for the Eto sensor probably. That covers my presentation. I'll give some, if you have any more questions, then thank you very much. My contact information is given right here. Here's my email, and my direct mobile number is right there. Call me anytime. Thank you very much.